Okay, this time let's try to solve a problem. It's called add two numbers. So adding two numbers is easy if you're using two integers. For example, 1, 2, 3 plus 4, 5, 6. So it should be equals to 6, 7, 8, right? So, but this time we are going to, so this two number is in linked list representation. So it could be ones next should be 2 and 3. And this is the linked list list 1. So the list 2 is 4, followed by 5, and then 6, and then now. So we are going to add them up. Therefore, the result could be 6 and 7 and 8. Eventually, it will point to out in the very end. So this is our problem. So our input should be two linked lists, and then our result should be one linked list. We will return the head of the linked list, which is the list node. So assuming that we have a class called list node, and then it will have a value and a pointer pointed to the next list node, something like this. And then, so I'm going to skip the constructor of a list node. So how are we going to solve this problem? So firstly, let's assume that the integer, both of the integer provided will not be negative. So our first assumption will be number should be positive. And what else should we assume? So we can assume that the length of each number may be different. So this will lead to another case, which is if we have one linked list, they only have one node, which is 1. So once we add it up, so it will be 1 plus 4, 5, 6, 450 and 6. So it will be 4, 5, 7. So we just increment by 1. So this will be a problem. So we cannot make the addition like this. So the best way to resolve this problem is to reverse the linked list at the beginning. So we calculate the lower digit all the way up to the highest number. So so this will be a valid assumption. So another assumption I'm going to make will be, let's say both of the number cannot be null. So we are sure that the input is not null. Of course, there's a possibility if we input the head, it will be null, so it's 0. Add it up to another 1, so we will end up with 456. Yeah, so we're going to exclude this problem because in our algorithm, we can easily say that if one list is null, then we're going to return another list, linked list. Okay, let's clear our thoughts a little bit. Let's jump into our algorithm this time. So let's go back to our original problem. So we may have running into another problem, which is the carry of the addition. So let's say we are adding 678 in this case. So 78, let's reverse. Let's put it into the representation of the linked list. So say if we reverse the linked list, it will be 8, followed by 7, and then null. So the second list, it will be 6, followed by 5, then 4, then null. So we can easily find the lowest digits and then to add them up. And then we will find out that the result will be 4, and then we are going to have carry of 1 at this time. So the next calculation, we are going to, it's going to be 7 plus 5 plus 1, which is 3. And then carry, still have carry of 1. And then the next one is 4. 4 plus 0, it could be 4, and then we added up the carry. And then this should be the final result. So after the calculation and reverse the list, it will be 5, 3, 4. So yeah, I'm assuming this is the correct answer. So let's jump into our coding. So we are going to put our signature like this. So we're going to return the linked list, which is a list node. Okay, so add to number. So our input is also a list node. Let's call it num list. Let's just call it list 1. And we have our second list called list 2. So we can do this checking first. Yeah, but even if we know that the number cannot be null. So if list 1 is equals to null, and we returned list 2. There's no need to edit. Okay, now we jump into the main logic. So we need to point it to the first element, and then adding them up and store it into our new list, which is our result list. So we need to create a dummy node here because we don't know which one to put as the next one. And then we also need a pointer to always get the next number let's call it current, and then we point it to our dummy node. So, okay. Okay, let's take a look at the list. So we can have a while loop here. If list one is not empty, because we're gonna traverse through list 1 and list 2. And list 2 is not equals to null. And both of these conditions, if both of these requirement met, then we can do the calculation. We need to define a carry for each addition. So we got the value here. Let's call it summed, and then it sums up the value of list 1 and value of list 2. And then these sums may be greater than 9, so it could be 10 to 18, right? So we need to get its true value that we're going to store into the node. Summed. So we can say that the carry, we can override the carry here. Oh, not yet. We need to add the carry into the sum. And then the value is the summed modulo 10. And then next carry will be summed divided 10. And then we're going to create a new list node. And then our current.next should point to this value. And then we're going to moving on to our next value. So once we finish the loop, we will have two conditions. One is that we are running out of list 1, because list 1 is shorter than list 2. The other case is we are running out of list 2. List 2's node is less than list 1. So we need to make the call to make sure that if list 1 is still not equals to null, then we carry on the calculation. So there's also a possibility that the next value is, we need to moving on, then list 1 should move to the next node, and then also list 2 will move to the next node. So the loops will not be, we'll have the end, an end. So the next one, the carry equals to, yeah, the same calculation happens here. And then just need to remember to move the node to the next one. We can apply the same logic to the other half, just in case if we still have a part of these two remain. Let's copy the logic here. And change it to 2. So after we finish here, we still need to check if we need an extra node to store the last carry over. So if carry is equals to 1, which means we are not yet finished. We are not yet finished. We need to take the new node. And then moving forward. And then in the very end, because we defined our dummy node here, and then the current pointer is to it act like a bucket to somehow receive every single value from the additions from each round, and then it will receive a value each round. So in this case, we only need to return dummy dot next. So we are done with our algorithm. Let's do a final check here, and then let's try to run it in the IDE. So I already created the framework here. So this node. Oh, there may be some capital letters. This is horrible naming conventions. This is not sum. Okay, let's try our algorithm. So say we have a linked list. Yeah, I already created a helper tool set which will convert integer array to a linked list. It's kind of handy. So it's like this, create a linked list. It's just an interesting for loop to collect all the nodes and link them together. And then I also have a very sweet printer to actually print it out. So print it out the list nicely like this. Okay, let's try. So if our first list is 3, 5, and our second list, now let's put it simple. want it. Oh, we need to reverse the linked list. So let's assume the number is 53, and then the next number, the second number is 81. So our final answer should be 134, right? So, yep, if I calculate it correctly. So this one is this one. So let's create a second list. Okay. Let's print it out. Remember this one and this two. Okay, the final number is 431, which is a reverse representation of 431. Let's try another extreme case. Let's try an empty list. So it will be 18 reverse, it will be 81. Let's try 9, 9, 9, and then we add it to 1. So it will be 0, 0, 0, and then 1. Oops, I think we had a problem here. We shouldn't output 10s here. I think I forgot to do one thing here. Which is the value should not be put into the list node directly. So this one will be, let's say, yeah, we should follow the same format. So this is still, we call it sum. And then we have the value here. Sum modulo 10. Okay, let's copy this logic. Yeah, we have to be really careful about mathematical calculation, especially in an ad hoc interview case. Let's try again. Is this correct? So our first number is 999, and then our next one is 1. So 1 add to 9, it should be 0, 0, 0, 1. The correct answer should be 0, 0, 0, 1. Let's do a debug here. Zero, zero, zero. So first time it adds up to 10. And then we module by 10, which is 0. And then our first node should be 0, 0, which is correct. Let's move to the next one. And then the next one, the first node is 9. The second one is already null, so we jump out of the loop. And then the first one, so the carry is still valid, is 1. And then we have our next 0 here. And then this time we have another 9. And then our carry is 0. So this is wrong. So this is wrong. Should I module by 10? I think this module is wrong. It should be 9. Because it has to be fit from 1 to 9, right? There's nothing like 10. Let's run it again. Why we lost the carry here? Skip this one. One. The second one is 9. This becomes 0. 10 minus 10. So let's try that. 10 and 0. This is typo here. It should be sum. It should be sum. Yeah, the same format as here. 10 is the correct number. Yeah, so the return is right. So this should be the code. Let's examine the last time. So this part is to check if either of the lists is empty. So in this part, we do need to create a dummy node because we have no idea where the pointer is going to point to. And then the current node is the node to collect all the additions, all the sums of the additions, and then divide it, and then module by 10, and then we collect the value and create a new node, and then we link it up together. And then we move to the next node in the loop. And so after we jumping out of loop, we have 3 different cases. The first case is both of them is running out of nodes, so we can jump into the conclusion of this part. So another case is that one list is running out of nodes, for example, list 2, and then list 1 still remains many nodes, so we need to traverse them and then put it into our, and then collect the number of it with our carry. And then the same things apply to list 2. And then in the very end, we need to check if the carry is 1, then we need to create another nodes to put it in the very end. So if need, we need to reverse the linked list and then output the correct answer. But I think in this format is pretty acceptable in this case. That's all for today.